Folks, as promised, I'll be giving an overview of how to install Llama on a Windows computer or on a Mac with Intel. Now, there are a lot of caveats involved here, but let me take it first high level, and then I'm going to show you a quick video of me working through every single step of the install in a Jupyter notebook with a Mac that has an Intel chip, not an M1. So a lot of warnings here I want to start with. Basically, if you have a Mac with an M1 chip or a Mac with an M2, it's going to work really well. You're going to get over 10 tokens per second, probably, even with only 8 gigabytes of RAM, which is the smallest M1 you can have. I've been running on a 2020 Mac M1 with 8 gigabytes, and it runs with over 10 tokens per second. It's also not that difficult to install. Generally, the instructions go fairly smoothly, and there aren't many prerequisites. If you have a Mac with an Intel chip, which I've also tested, and I'll show you a quick video, it's so much slower. It may not deliver even 2 tokens a second, probably more like 1 or a little bit less than 1 token a second. It's kind of interesting to set up just for the learning, but I don't see it being useful, certainly not useful to chat with, and not going to be something you use regularly. It's also trickier to install. You probably run into more issues along the way. So keep that in mind as well. And the most difficult is the Windows installation. Windows means on Windows, you'll have to download some packages. There are a few different options. I'll give you one option, which is the W64 dev kit. But you need to extract files. You need to open up an exe, and then you need to execute the make. So Windows is quite complicated. I've tried running on Windows in a number of ways, and even using the smallest possible GGML model, my computer usually crashes. Now, granted, it's a 2000 Dell computer with an i5 core, which is not very powerful, but generally it's going to be very challenging and can be tedious and easy to spend many hours, like I did, trying to get it installed. So my overall recommendations before I show the demo are, if you have an M1 or M2, it's definitely worth the experience, and it's kind of cool to chat. It's very quick to install. You can use the instructions below, or you can do an automated install with a Jupyter notebook, which I have available through this link here. If you don't have an M1 or M2, I recommend just using Google Colab. You can use a free machine using a T4 GPU. There's a free notebook here that will allow you to run Llama using a Google Colab notebook. Google Colab is also very flexible. It allows you to do fine tuning. It's very hard to do fine tuning on a Mac or a PC. The packages like GGML, there aren't as many options for doing fine tuning of a model. So if you're going to fine tune some kind of model, whether it's Llama 7B or even 13B, you could run on a free Colab notebook. You can fine tune those basically for free, and you'll have a lot more tools using the Transformers package. I'll put a link up to one of the videos on fine tuning if you're interested in that. But this video is focused on running inference. So this is focused on chatting with Llama on Windows or on Mac. All right, so let me just go through here very quickly an example for Windows, because then I'm going to jump into a live video showing me installed for Mac with an Intel chip. So for Windows, as with any install, you'll start with git clone of the Llama CCP repo. And then on Windows, you'll need to download some kind of installer or package that's going to help to make Llama CCP. The one that I found easiest was to download. You can just click on this link. It's W64 dev kit. You'll see it's a zipped file. Extract the zipped file, then navigate within that folder structure and run the .exe file. So you'll find a .exe file and just double click on it, and it will open up a new command prompt. In that command prompt, you need to move to where you have your llama.cpp folder. You can use CD to do that. You can also type in ls. If you type in ls, it will print out the files that are in the current folder, which helps you to navigate up or down. And once you've moved to llama CPP, you can issue the make command. Now, once compilation is finished, you need to download the model weights. You can use this link into your Llama CPP folder. That's a typo, shouldn't be CCP. And once you are in that folder with the model weights, then you can run this command here on Mac, or if you're on Windows, run server.exe with the same command. Now, if you haven't installed with some kind of GPU acceleration, which happens easily with M1, then this NGL, this is offloading of layers to the GPU. That's not going to have any effect if you've not compiled with GPU support. And then this -C, this is the context length. I think actually this is the default. If you don't set it, it's 2048. But you could set it to something lower. That might reduce a little bit your machine requirements. But ultimately, that's not the main issue. The main issue is the memory required in handling the model. So let's cut to a video where I do the installation on Llama on Mac with an Intel chip. I even use a model, although I don't mention it, that's even smaller than this. This model here is about, I think, 3.5 gigabytes. I use a model that's about 2.5 or 2.6. So it's the very smallest model I could use to try and get the speed up as much as possible. Any questions, let us know in the chat below. Here's the demo. Cheers. And here's the demo for installing Jupyter Lab and running Llama on a Mac with an Intel chip. So I'm here in a folder. I know it's small font on the left, but I will show you larger font on the right. I've got a folder called Jupyter Llama Laptop, and I've got the Jupyter Notebook with the automatic install within it. Now I'm going to install Jupyter Lab, but just before I do that, let me just refresh this page. So I'm going to install venv. I've already got that installed. It'll allow me to set up a virtual environment or sandbox. Now I will create a venv called llamaenv. Let me move me out of the way. Now I will activate that virtual environment once it's set up. Just waiting on it to get set up there. Don't know why it's slow today. Okay, there we go. So I've activated that. And now I'm going to install Jupyter Lab within the virtual environment. This is helpful because if you install in the environment, Jupyter will find the paths more easily. There'll be less errors. So I recommend installing Jupyter Lab in the venv. Now I'm going to install IPY kernel, which will allow me to set the kernel to llamaenv. So it'll allow Jupyter to run with the specific environment. Okay, so that is done. And I just mentioned I would now activate So install Jupyter Lab, I'll install Jupyter kernel, IPY kernel. Maybe, I already installed that, let's see. Activate that kernel now, and I just have a typo here, that should be capital L. I'll fix the documentation after. And then we'll be ready to run Jupyter Lab. Okay, so the kernel is running here, that's correct. And then just run all cells. Okay, so we won't enable the search history and we won't enable archive search. So here it's Mac for just Mac. So we've just cloned Llama CCP. Then the compile will start. So now it's compiling, and that's just been compiled. And the next step is to try and download the file, the model weights. Okay, so we've just installed, downloaded Llama 2, which is good. The model weights are downloaded. So there's a little more installation going right now. Okay, now we're being asked for the choice, so I'm going to give a short context length. And let's see here. This is where everything should display. Okay. So I'm going to hard refresh. All right. Well, that took basically 2.5 minutes to generate that amount of words. I'm guessing, that is more than 5 tokens. It's probably like 15 tokens. But still, you can see just how slow that is if you want to run on Mac with Intel chip.